The amount of force per unit of area is called pressure. When the force is perpendicular to the surface area, P is the pressure and A is the area over which the force acts. Pressure is measured in newtons per square meter, or pascals. 1 newton per square meter is equal to 1 pascal. The force of the weight of the book on the table is the same in either case. The upright book exerts the same force but greater pressure against the supporting surface because the area of contact is smaller. You exert more pressure against the ground when you stand on one foot than when you stand on both feet due to the smaller area of contact. The smaller the area supporting a force, the greater the pressure on that surface. In this picture, the driving force per nail isn't enough to puncture the skin.
Okay, you guys protect yourself. Protect yourself. Yeah, okay. Okay. Here we go, gang. Here we go. Hurry. 1, 2. Oh, wait, I should tell you. I should tell you, this is not mind over matter. It's not what kind of granola or bean sprouts or meditation that Paul does. You know what this is all about, gang? Physics. Yeah. Okay, let's see it. Here we go. 1, 2, 3. Ha!
So how does physics prevent this guy from getting hurt? A single nail has a pretty small area at the tip, but if you multiply that by the hundreds and hundreds of nails in contact with his skin, it reduces the pressure enough to make him safe. Still, don't do this at home. Galileo showed that falling objects accelerate equally, regardless of their masses. This is strictly true if air resistance is negligible. It's approximately true when the air resistance is very small compared with the mass of the falling object. In Galileo's famous demonstration, a 10-kilogram cannonball and a 1-kilogram stone strike the ground at nearly the same time. This experiment demolished Aristotle's idea that an object that weighs 10 times as much as another should fall 10 times faster than the lighter object. Remember that mass, the amount of matter, and weight, the force due to gravity, are proportional. A 10-kilogram cannonball experiences 10 times as much gravitational force as a 1-kilogram stone. But Newton's second law says that acceleration is affected by mass. 10 times as much force acting on 10 times as much mass produces the same acceleration. The ratio of weight to mass is the same for these or any object. All freely falling objects undergo the same acceleration at the same place on Earth. A feather and a coin fall with equal accelerations in a vacuum, but not at all in the presence of air. When falling in air, the coins fall quickly while the feather flutters to the ground. The force due to air resistance diminishes the net force acting on falling objects. You experience the force due to air resistance when you stick your hand out the window of a moving car. If the car moves faster, the force on your hand increases. If instead of using your hand you hold a book out of the window with the large side facing forward, the air resistance force is much larger than on your hand at the same speed. Air resistance force is proportional to speed and frontal area. Terminal speed is the speed when the acceleration of a falling object is zero because friction balances the weight. Skydivers reach terminal speed when air resistance equals weight. A falling feather reaches its terminal speed very quickly. Its area is large relative to its small weight, so air resistance has a large effect on the feather's motion. A coin has a relatively small area compared to its weight, so the coin will have to fall faster to reach its terminal speed. The terminal speed for a skydiver varies from about 150 to 200 kilometers per hour, depending on the weight and orientation of the body. A heavier person will reach a greater terminal speed than a lighter person. Body orientation also makes a difference. More air is encountered when the body is spread out and the surface area is increased. The flying squirrel increases its area by spreading out. This increases air resistance and decreases the speed of its fall. A parachute greatly increases air resistance and cuts the terminal speed down to 15 to 25 kilometers per hour, slow enough for a safe landing. At low speeds, air resistance is often negligible, but at high speeds it can make quite a difference. If you hold a baseball and a tennis ball at arm's length and release them at the same time, you'll see them strike the floor at the same time. But if you drop them from the top of a building, you'll notice the heavier baseball strikes the ground first. This stroboscopic photo shows a golf ball and a foam ball falling in air. The heavier golf ball is more effective in overcoming air resistance, so its acceleration is greater.